This is a video on how to determine the type of chemical reaction you have. There are actually two words that I will use interchangeably, but they're not. One is chemical reaction, the other is chemical equation. The difference between the two is a chemical reaction is what you're looking at, and the chemical equation is what you write down. But I will use them interchangeably. With a chemical reaction, there is a symbol. It's an arrow pointing right. Is an indication of a chemical reaction. On the left-hand side of that arrow are what they call reactants, things that go into chemical reactions. And what comes out after the reactants reorganize themselves are called products, and that's on the right side of the arrow. If you have more than one reactant, you separate them by plus signs, which is the same thing as you do if you have more than one product. You separate them by plus signs. So if a chemical reaction is simply the material going in reorganizing to come out, then the law of conservation must apply. And we'll get more into that when we do balancing and stoichiometry and other applications of chemical reactions. So by now you should have opened up this page, and also at the bottom there's a link to another page, which is actually this page here. And what I did was the other page, which explains the 5 types of chemical reactions, is actually a PowerPoint presentation from this Oak Park Unified School District website, and I put in the URL because what I did is I downloaded it and put it into my website just for ease, just in case the link goes away. I'll still have the original, but I did not produce this. Somebody else did, and it's from this location. I just wanted to source it for them. So you need to click on it. And of course, this down here is the YouTube video that you're listening to now. You would have clicked on it. So the 5 different types of chemical reactions are synthesis, decomposition, single replacement, double replacement, and combustion. And as you can see from up here, there's other names for them too. Those aren't the only chemical reactions there are. It's just the most common ones for first year. So what I'll do is I'll quickly go through how you can tell from a chemical equation if it's synthesis or decomposition or any of them. And I'll use their worksheet to help. Okay. So going over to theirs, one of the things that they did is at the end they started to put some organic chemistry naming. So we just won't even talk about that because that's not we do in first year. We do that in AP. So the first thing they do is talk about observations of chemical reaction. We already know what those are. And here are the 5 different types. So the first is synthesis. And you know it's a synthesis reaction because you're taking multiple things and you're making it into one product. So the key is looking for one product. Most of the times it's the elements making into a compound, but that's not always the case. Again, you can tell it's a synthesis because you have one product. That doesn't mean you don't have more than one of those products. It just means you produce one product. There's no second product over here, which you would see with a plus sign and another symbol. So that's synthesis. Okay, and then he gives you an example. Okay, decomposition is not 1. He screwed up. It's supposed to be 2, but that's all right. I mean, it's okay. Decomposition is the opposite. You know you have a decomposition reaction because you're starting off with one reactant and you're making more products. It doesn't have to be 2 products that you make. It just, you're starting with one product, one reactant, and you're producing more than one product. Okay? Again, your reactant doesn't have to be just one. They can have coefficients other than one. So that's the second way of doing it. And again, he gives you an example of it. A single replacement reaction is exactly what you would think it would be. You're replacing one thing. So what you see here is that here's a compound, BC, and here's an element, and that's the key. For your level, what you have is you have an element and a compound, and what happens is the element, outside element, will displace one or replace one of the two materials in the compound, and that material will be kicked out as an element. So that's what happens. A will replace B, B gets kicked out as an element, here's the element by itself, and then you have a compound between A and C. And that's how a single replacement reaction works. We will get into the specifics of it, but that's how you can tell. Because you have an element in a compound to form an element in a compound. Next one, and he's going to give you an example. Let's move it a little, sorry. He'll give you an example, okay, and we'll get into it in gory detail. And the other one is double replacement reaction, which double replacement reaction is exactly what you think. You replace, you switch both things, okay? So if you look here, you have a compound plus a compound to give you a compound plus a compound. That's the easiest way of remembering a double replacement, is you have a compound, two compounds in the reactant, and you form two compounds in the product which aren't the same, okay? And there's a bunch of ways in which you can do it, but you can see what happens here is that one of these, let's say, what happens here is that B and D stay the same on the product side, and you're switching A and C, okay? But again, the way you can figure it, you can see it is that a compound plus a compound will give you, in the reactants, will give you a compound plus a compound in the products, the replacement. And the last one is combustion, and everybody knows that combustion is oxygen, okay? It's a carbon source, that's what this is. It has to have carbon in it, and it can't be CO or CO2 or just carbon. Oxygen is a reactant, and you form CO2 and water. That's combustion. So that's how you can tell. There's more than that in combustion, and it's a myriad of different explanations, which we'll get into a little, but that's the general. Okay, a combustion reaction, your products are CO2 and water, and you're using a carbon source, and it can be CH and O2 or just C and H. And oxygen is always one of the reactants. Okay, and then what he does is he goes through and he does a bunch of examples, and again, it's organic. So we don't need to deal with that. So those are the five major types of chemical reactions. Synthesis, you know, because it's just producing one product. Decomposition, because you have one reactant. Single replacement reaction, because you have an element plus a compound to give you an element plus a compound. And double replacement, because you have two compounds in the reactant and you form two compounds in the product. Okay? Again, that's the easiest way of doing it. And that's what you're going to do. Somebody's going to give you a chemical equation, and then you're going to look at it, and you can use those things to figure out if it's synthesis, decomposition, single replacement, double replacement.